Hello and welcome to this applied Hess's law cycle walkthrough question. So it's just the top one out of these four. It's from our summer work we set, and we're going to have a look at just doing the top one, and then you can apply the ideas to the other three. So first of all, let's look at the technique. The technique is to write the equation across the top. So if I activate my laser pointer, there we go. This is the equation we're going to write across the top for a Hess cycle. You check the table for the type of enthalpy data, and then you draw the appropriate template. There's two options, so let's have a look at how we choose each option. The key lies in the type of enthalpy data that you're given. So if you're given delta CH data, you use the top version. If you're given delta FH data, you use the bottom version. So like I said, I'm just going to do the first part, and you can try the others out yourself. Okay, so let's look at the first part blown up a little bit on the screen. So they want us to give the answers to three sig figs and the standard form. And just to remind ourselves, it's delta FH data we're working with. So just remembering the 3 points of the technique we talked about a moment ago, you start off by putting the equation across the top, and then that can be ticked off. Next thing to do is to put the elements in their standard states. You don't have to write them out as formulae or symbols. I prefer to do this formula or symbol because it helps me keep track of what's changing into what. So now what we've done is we've chosen the correct type of cycle based on the type of enthalpy data we're given. So we can start putting the numbers in. So you'll see that I've taken the arrows and I've pointed them up at the compounds. I've ignored the 3.502. That doesn't get an arrow because it's an uncombined element, so that gets a delta FH value of 0. Now what they want me to work out is the delta FH of water. You can see it in the question. So what we have to do is take this and isolate that somehow mathematically. So the way to do this is to think about where you're starting. You're starting at the uncombined elements and you're finishing off with water. So you draw an indirect route. We can't do the direct route because we're trying to work that out, but the indirect route we can do. So we draw a little dotted arrow representing the indirect route. Okay, so we follow the dotted line and add the values up as you go, reversing their sign if the direction of travel of the dotted line goes against the blue enthalpy arrows. So, in the case of minus 84, the direction of travel, which is up that way, points in the same direction as my blue arrow, so I keep that minus sign. I do the same for my minus 1560. So I'm going to tick those two off because they've been processed and dealt with. Now I also add in the minus 788, but why do I say equals minus 788? Because the minus 788 is part of the direct route. These two arrows here represent the direct route from my starting point to my finishing point. Part of that direct route I'm trying to work out. So the minus 788 goes in with the 3 delta FH H2O. Now I need to get rid of this so that this becomes a subject. So I take this and I put this over on the left-hand side next to these two. So let's clear some space to do that. This is what it'll look like. You'll see that as I move the minus 788 over, it becomes plus 788. So typing it into my calculator gives me minus 856. I divide it by 3 because there are 3 delta FHs. I only want one of them. That gives me minus 285.3. So putting in 3 sig figs and in standard form, not forgetting, of course, that it still stays as minus 2.85. It's minus 2.85 times 10 to the power of 2. So a quick look at the mark scheme. There's 4 marks available normally on this type of question. First mark would be for attempting to do a Hess cycle. Second mark would be for application of Hess's law, so both routes are equal to one another. The third mark is divided by 3 because there's 3 H2O in the equation. And the fourth mark is for applying 3 sig figs and standard form as instructed. Okay, thanks for listening. Until next time, see you soon.